Thank you for attending this session. I hope you had an interesting and exciting day so far here at the NAV Tech Days. So this is going to be the last session for today. It's going to be about keys and indexes in NAV, what we have. Before we start, let me briefly introduce myself. As you can see, I'm around in the Navision world also for quite some time. So I was in the keynote, I was one of the guys between the 10 and the 15 years, somewhere between. And I'm also almost as long I'm around in the internet forum, Bibuso and other forums. And I'm really, really happy to see so many familiar faces, or at least the nicknames on your cards are quite familiar to me. And I also see a lot of familiar friends. So I want to talk about indexes and keys, what this actually is, how you can use this in NAV, what impact it has actually on the performance. As you probably know, I have a 100% focus on NAV and SQL Server performance optimization. And this is actually one important chapter out of this context I want to present to you. I would like to have a very strong focus on the demonstration, keeping the PowerPoint slides down to a minimum. And what I want to show you is what you can do also today. So I will not have a look into the future, what you will be maybe able to do with NAV 7 or anything. No, I want to highlight what is possible today, what you can do right now with your installations or your customers' installations. Before we go to the hardcore content, just some basics. Which is necessary to point out. I guess most of you are also originating from the native NAV world. And we are always talking about keys, and then other guys are talking about indexes. Yeah, what the hell, what's the difference between a key and what's an index? Something like this. To keep it simple, a key is actually kind of constraint, a kind of rule, so to speak. And the most famous key we have in NAV is the primary key. And there's a rule on this because the rule of this primary key says that every single key value has to be unique. So this is the purpose of a key. It's a constraint kind of rule. Everything else is actually just an index. An index is a helping structure to retrieve data, no more and no less. In NAV, we're always mixing the terms up. We're always talking about keys, primary keys, secondary keys. Actually, this is wrong. Yeah, because if you remember customer table, there is a key called search name. Yeah, what is the constraint here? What's the rule about the search name? There is no rules, there's actually no keys. Actually, this term originates from the older world, from the native C-side server, where a key indeed was used for all and everything, for data retrieval, sorting, and the SIF management. But it's absolutely necessary to distinguish between those two objects actually with SQL Server, because it's different things, and they need to be handled completely different. So, just have to fill myself up. So an index is a helping structure to retrieve data. You all have an index finger, I hope so. Yeah, because you use it to point something out. This helps you to point something out. And every one of you is also working with indexes on a daily basis. And just to give you an example you're hopefully familiar with, I'm having this little book here that's the yellow pages. This is from my area, from my home turf at Nuremberg area. So now assuming we want to look up something from this book. So give me anything you want to look up. Striptease clubs, okay. No problem about that. Okay, we have a reception, we don't need to go to the strip bars. Anyway, so what you don't do naturally, you won't throw this in the air, open it some page. Oh, pity that's automobile garages or stuff like this. No striptease clubs today, I'm sorry. So you have to bring your car to the garage. No, you won't proceed like this. Because the natural thing you do, because once in your life you have learned that either in the beginning of this book or at the end, there is such a helping structure. There is an index. In this case, the index is just a list of all the branches and pointing to the page where the branch starts. So what you naturally will do is, because you have kind of statistic about this, you know that there is an index that helps you to process this query. You will go to the rear end of this book where you find the index about the branches. So what you will do now is you just simply scan through this index, through this helping structure. You know that's sorted alphabetically. Every branch is in alphabetic order listed here. And sooner or later, I will find my striptease clubs. And then it tells me, okay, the striptease clubs, they all start at page 150. So from this helping structure, from this index, I will jump over to the real page, to the 150, and there I will find all my striptease clubs, including the name, also the names sorted by in alphabetic order. I will find the address, the phone number, and I don't know, maybe the prices. Yeah, I don't know. I have no idea how striptease clubs work. So this is a helping structure to retrieve the data quickly. That is the idea of this. Now imagine this. Okay. Take a deep breath. So my helping structure. Drop index, speak in SQL. Now it's gone. Pity. So what? I still want some entertainment for tonight. So what do I have to do? No helping structure. What I need to do now is I have to scan through every page. I have to read page by page by page by page by page. And someday I will reach my page 150 where all the strip clubs start. So this scanning actually caused a lot more of I/O. Yeah, I had to read more pages. So more logical I/O I have to accomplish. Still, in a decent time, I still get my result. I find my strip clubs. And that is because this little book here has a defined physical sorting. So the data within this book is actually grouped. It is grouped by the branches in alphabetic order. And within each branch, it's also ordered by a company name or whatsoever. So the data is clustered. Actually, I have a clustered index, so to speak. So now it's going to be a little more difficult. Now imagine this. Up. And the other thingy here. Yeah, grateful we had good lunch. So, and that. So, hooray. That's called a heap. Yeah, indeed it is. So, no more physical sorting. It's a heap. And this is actually, I would say a smart heap, because in reality a heap looks different. A heap looks like this. So, heap means that the data is stored wherever there is some space. So now I want to look up the striptease clubs. I'm screwed. I have to perform a lot of physical I/O and logical I/O and read every bloody page of this book, hopefully finding someday my striptease clubs. So that means without a helping structure, without an index, it's going to be a difficult task. Without having a clustered index, without having data in a grouped way, I'm even more screwed. And actually for the SQL server, it's exactly the same. Or I hope that you're not storing striptease clubs in your SQL database, but actually it doesn't matter what kind of data you store, it's always the same. So this is the general idea how indexes actually work. And believe me, it's exactly the same with SQL Server. Helping structures to retrieve data. Now, having a look from a more abstract perspective, we're talking about so-called balanced trees. And this actually happens because when data is indexed, the index pages have a limited space of 8 kilobytes. So I cannot indefinitely index data on these pages. So sooner or later, I will need another page and another page and another page. This is what we have here, just a straight list without further index nodes or something. SQL Server behaves differently. It will create intermediate nodes. That's actually kind of routing points that telling the SQL Server to go either this way or the other way. So we have a lot of index nodes, intermediate nodes, and the very top level, the entry points in such an index is called the root nodes. Basically, every index is non-clustered. It's just a helping structure. And we have one clustered index actually. And the very difference is only that while all other indexes just exist of index values, for example, posting groups or whatsoever, the clustered index in the rear end also has the rest of the records. So all the remaining data, it's not just index values, like, for example, posting groups or post codes, zip codes, whatsoever. If you're speaking about the customer tables, for example, the index is built up of customer numbers, but at the end of this index, we also find the rest of the records, the name, the address, the posting groups, and so on. So that's how the clustered index actually defines how the data is physically stored. This means we have one clustered index because we can arrange the data just once in a certain way, and we can have, let's say, basically infinite non-clustered indexes. I think the technical limit for SQL Server is 999. In NAV, if you fiddle with NAV keys and indexes, I think we're still limited down to 40 keys, which is still too much if you have that many. One thing I also want to mention right now, these indexes can be used in actually two different ways, which I also demonstrate a little bit. The quick way is to seek an index. Seek means to run through an index top-down. Like a query, I want to find out all records of number 7, posting group number 7. Then SQL Server can use these routing points to quickly seek through this index, finally retrieving the record or the records belonging to this filter criteria. If I would have a different query, something like this, so a wildcard 7 wildcard, that would be something like, give me all phone numbers which contain a 7. Yeah, screwed. What should I do? Of course, I have to start from the very beginning to read this book. Yeah, that's what the wildcard in the beginning tells. Start at the beginning. Then I sooner or later will get the 7. But the wildcard at the end actually prevents the SQL Server to find an end. Where should it exit? Yeah. Maybe there's something beyond the 7. Is there 17, 27? Who knows? So in most cases, it is forced to scan to the rear end. So it's important to understand top-down, that's a seek. And going from left to right, a sequential reading of the leaf node level of an index is called a scan. And just this very, very simple example shows what the problem is with these seeks and scans actually. In the first example, when I was properly seeking through this index, the SQL Server had to read 1, 2, 3 pages. And if it has to perform a scan, it's 1, 2, 3, 4 pages. So the I/O is higher when SQL Server is forced to scan. And just to have this back in your minds, because we will come back to this in a minute. Besides these standard types, that's the one we actually have out of the box in NAV. There's also something else to mention, that Navision is not taking full advantage of everything that SQL Server provides. SQL Server has lots of more options when creating indexes and stuff, like included columns or filtered indexes, descending indexes and stuff like this. Just because we will use it afterwards, where hopefully we'll get a little bit more clear. The most important feature, and this is really cool, and we can also benefit from this within NAV, is the so-called included columns. Included columns means you have an index, a normal balanced tree, and at the end of this index, you attach just certain fields. So actually an excerpt from the table. So while the clustered index has the full record, all the 150 fields or whatsoever, you can specify an index where you just extract from the table, or actually copy from the table, just 1 or 2 fields and attach them to the end of such an index. And the idea of this, or how this could help you, I will show you later on. In NAV, we have a standard way of translating from key to index. Actually, every primary key is, of course, in SQL Server also the primary key, so it means it defines the uniqueness of a record, and usually it's also the clustered index. So data is usually grouped by primary key, which is a good idea. Only in some cases, this rule is broken, so to speak. If you run the newer NAV versions, for example, you will see that there's a different key used for clustering on sales line, purchase line, and something like this for some reason. Everything else, all other keys we have are translated into unique non-clustered indexes. From the naming, it's easy to actually read them from Management Studio. Primary keys are always ending with a $0, and all the other indexes are just numbered 1, 2, 3, 4, and so on. There is another thingy we can actually use. That's the so-called foreign key. I don't want to spend too much time on this. Those who are programming SQL or are familiar with database and relational programming hopefully know what a foreign key is. That's a really tight connection between, a tight reference between a field and the primary key of other field. So much harder or much tighter than we have the table relations. We can use it in Navision because there's a database property called maintain relations. If you enable this, then all our logical table relations we have in NAV will be transformed into real foreign keys for SQL Server. I highly recommend not to do this. Never, never, never. Because you know how many table relations we have in NAV. That's a couple of thousands. And if you create thousands of constraints, that might be a benefit for the data integrity, but if you change data or insert data, you're screwed, because checking all these constraints just takes forever. So if you need foreign keys, then you have to create them manually, precisely where you need them, and not throughout the whole database. Yeah, and this thingy with the clustered indexes, that's something we cannot use in NAV. Not yet. Since NAV 4, we have a property that's called SQL index, besides other key properties. This SQL index property is actually, or the idea was, to meddle actually with this standard translation from key to index. There was some reason to use this in the older Navision versions, means NAV 4 and the very early 5.0 before Service Pack 1. Today, my advice is pretty short. Don't use it. Leave the SQL index property alone for a reason that will be clear in a minute or two later on. So means usually it should be empty today for good reason. Leave it empty. If there's something in it, don't touch it without knowing what you do. So. And the reason for all this is the curse of the cursor. Yeah, maybe you should dim the light to get a little bit scarier atmosphere here. So. Cursors. What is a cursor? A cursor is simplified as kind of a bubble shell around a number of records. It's a variable that exists of multiple records. And NAV, in some cases, declares such cursors with the idea to have such an amount of records to actually loop through this result. And I want to show you what is the pain with this. Just introducing my test environment quickly. That's on SQL Server 2008 R2, running a 5 Service Pack 1 Update 2 database. And there I have a GL entry table. I hope you're familiar with the GL entry table, which has about 3 million records. So it's a decent size, so even for Coronas, well, especially for Coronas. And so having a look from an NAV perspective, so just that we have it back in our minds. We have a primary key, that's the entry number. No SQL index, the index is maintained, and the data is clustered by entry number. So the records are physically sorted by this number. And another key or index I want to highlight, that's this one, GL account number, posting date. It's also maintained and existing, so to speak. Okay. So that I'm able to investigate what will happen in a second. Here I have a query which is actually looking into the procedure cache or the cache from the SQL server. So there's some grep data in it, and I'm clearing it. Maybe at this moment I should mention everything you see, the slides, the demo scripts, and also the demo objects I'm using, you should find already now for download on my blog. So you can take this all home with you and try it out. Okay, so the cache should be empty. And now I'm running a very, very simple NAV code. Code you probably find in all your customizations or programmings. I'm just applying a filter on the GL account number, on the posting date, and then I run a find minus. No more, no less. I do not specify a set current key. A key in NAV is just defining the sorting order. If no special sorting order is defined, then primary key sorting will be used. So now I'm executing this, so it doesn't display anything. And now we can check in the cache again. So here it is. So this is how the NAV code is actually translated into this statement. It's a select statement, filtering on posting date and GL account number. And as no sorting order was defined, it's ordering by entry number. This is what a find minus does. So now when we look at the consumption, so at the I/O that was produced by this query, then we see that this query consumed more than 130,000 pages. A data page is 8 kilobyte, so 130,000 multiplied with 8K. That's roughly 1 gigabyte of memory consumption just for this query. This actually was executed so quick because I warmed this query up before. The first time running it, it takes 30 seconds or longer. That is the pain. So what happened? I have another code where I have this visible what actually is going on. This is how the query actually will look like. And what we don't see, but in an instant, is that NAV, you can see that, or maybe down, was declaring a so-called dynamic cursor. And this query here is just reproducing this, because here I can show you the execution plan. The execution plan displays how SQL Server actually processed this query. What? Oh, maybe I should have this. Still 130,000 pages were read. And when I check the execution plan, I see, you always have to read it from right to left, that a so-called clustered index scan was performed. You also see it from the arrow. So that means it was sequentially reading the clustered index, which is the table. The clustered index actually is the table. So where is this 130,000 reads coming from? Now if we check out this index, that's ID 1, that's our primary key, that is the clustered index. You can also see it here, which is the object that is this primary key index, the clustered index was used. And with some dynamic management, you can also check on the details of this index. And here we can see that this index actually has 3 levels. The first one here, that's the most detailed level, that's the leaf node level. So the leaf node level is 130,000 pages wide. So it's a tree with 130,000 pages, but only 3 levels deep. So that means what we have seen here is that the complete table has been scanned. Yeah, GL entry, that's a kind of data grave, so you always insert data, never get rid of anything. So the more records you have, the longer it will take, a complete scan. So that is what's consuming time, that's what's consuming system resources, memory, CPU. That is bad performance. How comes this? And the reason is this. I almost said bloody cursor, which of course I do not say. That's not a bloody cursor. It's maybe a stupid cursor, but not a bloody one. Anyway, when looking at this query, sorry, that's this one. A dynamic cursor implicitly tells the SQL server that my sorting order is more important than the filter. That's actually what comes together with a dynamic cursor when dynamic cursor is declared. So that means that this query tells the SQL server, this here is important, this not. So this is the reason why it will try to pick an index which matches to the sorting order, which is the primary key, which is the clustered index. Pity, because basically we know we have a key on these fields. We have such an index, if you remember this. So why isn't it picking this? And that's due to this dynamic cursor. So sorting order overrules the filter. So to have a dynamic cursor work more or less properly, it is necessary to indeed specify a sorting order. So what I do here is I use the setCurrentKey command, sort it by these fields, and apply the same filter, find minus. Running this, and check in the cache again. And actually it's this query. So, and the difference is actually here, that now the sorting order is defined. It's ordered by GL account number and so on. It's still a dynamic cursor. But no problem with this, obviously. So I also have a cursor using the right sorting order so that you can check on the execution plan. So this query is executed with 3 reads. And the execution plan shows us that it's using this index $1. That's this index GL account number posting date, and only 3 reads. And the reason for this is, we also check on the technical specifications or the details of this second index. This index is, 10,000 pages wide, and it also just has 3 levels. In this case, SQL Server was able to run a proper seek, so it means per level it was just reading 1 page. So 1, 2, 3 for every level, seeking top down. That's it. That's good performance. So that means a dynamic cursor screws up the system. And the pity is, in the old days in NAV4 and so on, it wasn't necessary to take care about the sorting order. You just could program, and if the sorting order wasn't important, you just fire your query, you find minus, everything works. Because the older Navisions were not using dynamic cursors, they were using fast-forward cursors. And fast-forward cursors optimize a query on the filter and not on a sorting order. And this is what you maybe have experienced when upgrading a customer from NAV4 to NAV5 or 6. Then overnight you're screwed. Performance vanished. Because you did not care about the sorting order. And now welcome the dynamic cursors and you're cursed. Yeah. So what does that mean? So that means that now we need, for every filter we apply, we have to create appropriate key we can use for the sorting order. Of course, that would be totally stupid. Yeah, of course, if for every bloody filter condition, if I want to create a key, yes, of course, I can promise you, you will have a 100% read-optimized system, but you cannot insert anything. Because, of course, every index you add has to be maintained. It's so-called cost per record. When you insert a record, all these indexes have to be maintained. So the more indexes you have, the more you slow down the write performance. And, of course, you need to find the balance in between. So this is definitely not the solution, just to fill with the dynamic cursors and create keys for that. Because actually this is solved by a not-so-new command, find set. That's the solution. So instead of filling with the cursors, the solution is avoiding the cursors. Because a find set command does firstly not create a cursor. So if I fire exactly the same query, the same filter, and now instead of the find minus, I'm using the find set command. Fire. And again into the cache. So here, please regard, we have a top clause here, top 501 in this case. Then we have the same filters and sorting order by entry number. It's consuming 3 reads, so it's just 24K instead of 1 gigabyte, and it's no cursor. So a find set does not declare a cursor. SQL Server could optimize a query on the where clause, on the filter, and if there is appropriate index, it will pick it. Yeah, it doesn't care about the sorting order. A sorting order has just priority 2. So that I hope you believe me that in this case, I don't want to show you execution plan. I can do that. It's exactly also doing a seek through $1. So that also means that for a find set command, the sorting order is not that important. Of course, it makes a slight difference on the CPU load regarding sorting. But I have a last example here using the find set command with a right key. Run that again. Check the cache. So we will see here that's our 2 queries. Yeah, the one with the wrong sorting order, the one with the right sorting order. From an I/O perspective, there is no difference. The only difference is that in this case, the data has to be sorted. In this case, not really. That's how it's reducing a little bit CPU load. So this is 100% plus, and this is fair enough. Find set, that's the solution. Find set has actually several purposes. Actually, the history in the old times, we just had this find minus command. And find minus actually means that every data, every record is loaded into the memory. A cursor is declared with all the records in the filter, regardless if it was 1 record or if it was 10 million records. That was causing super load on the server, and then the data is shipped to the client, also causing super load on the clients. The idea of find set is to deal with these problems by splitting up the result. And that's why we have this database property here, the caching record set size. And this defines the top clause. And the idea is to have a smaller package of records loaded into the RAM, because in the old days it was 500. This is sufficient enough. You know your vision systems. If you have a filter and if you query records, I dare say 90% it's way less than 500 records. As long as the actual result is equal or below this 500 in my example, no cursor is declared. If the actual result, so the filter, would retrieve more records, let's say 1,000 or 5,000, and you loop through the first 500, then when it's reaching the end of this result set, then the rest of the data will be queried by a cursor. So then it behaves exactly like a find minus. And this is, of course, I say always use the find set command, because then at least the first run is always okay. And if you have a very huge result set, okay, then the rest is something to maybe fiddle with. Have in mind that in NAV 2009, this was reduced down to 50. And the idea is actually thinking on a role tailor scenario, because actually we talk about, speaking about, let's say, memory packages. So in this classic client architecture, we have fat clients. So every client has its own memory package. In the service tier, we have up to 50 processes running on the service tier. So we have multiple memory packages, and that was the idea why the package size was reduced, because we are still on 32-bit limited memory, so having smaller packages not to encounter any memory problems. And this means, on the other hand, if you're using 2009 Classic, you can easily increase that. And this actually depends on the hardware resources of the clients, or maybe the Citrix environment. Even in a role-tailored scenario, I would at least set this always to 100. That's a decent size, because 50 really sucks, because you're always running into cursor issues. So something between 100 and 1,000, that might be feasible, so you avoid cursor issues. Cursors are today a main reason for problematic performance. And the good news is, in NAV 7, there will be no more cursors. The way of how data is queried will be totally different. I think I'm not violating a non-disclosure agreement here, calling so-called MARS, multiple active result sets, a different technology, which rocks. Okay, so just a brief overview about the commands. Have in mind, find set cannot be used with a descending order. And if you want to modify something in the result, have in mind there are two options, this for update and for key update. So usually you should use a find set false false. If you have to use the true parameter, then be aware that this is behaving exactly like using a log table command. So using find set true actually maybe will solve a cursor problem, but raise a blocking problem. So be aware of this. I have added some links here to my blog, where you also find some more examples, and also to Eric's Waldorf's blog, you hopefully know, where you find a lot of examples how NAV code is translated into SQL and what is the impact of everything and so on. So actually that was the slides. So that means that is actually a natural thing that we will have performance problems due to, let's say, wrong usage of index or due to missing indexes. They aren't there. So the challenge is actually first find out about such problems and then solve them quickly. And I want to show you how this could be easily done, actually. And the tool of our choice here is the SQL profiler. So I'm connecting to this. I have prepared some template. A template is just a predefined collection, selection of events and columns. This download package on my blog also contains some profiler templates and a README telling you how to install this. That's very simple. So a selection of events, and then just have to save it into the proper path. So I'm recording the data, saving it to file. And this is what I highly recommend. When you record the traces or something, always do it into the file system. Because of course, technically you could also record into a table, but then you're causing additional workload on the server. So you might raise a problem and record that problem. So you're recording your problem, you just recreate it. You get my point, I guess. So anyway, and that's important for the dynamics partners here. If you put it into the file system, you can record on customer sites and then get the trace file back to your office and do the investigation there. It's also maybe an advantage. I don't want to use that rollover, just having a file of 50 megabytes at max. Of course, if I press execute now, it will record everything that happens on the NAV system. I don't want to see what is good, I want to find out what's bad. And what we have seen so far, the best indicator for bad performing queries, that's the I/O they consume. That's the number of page reads. And that's why I can filter here. And you have seen even a 3 million record table with 130,000 pages wide only has 3 levels. So usually all these operations in SQL Server should be accomplished with less than 10 reads. So there might be stupid things that then a few dozens of reads are consumed, maybe several hundreds. But what I say, kind of best practice, is everything that takes more than 1,000 reads, that's not plausible. This is something where SQL Server starts to do something stupid. This is something I want to investigate. This is a Kronos fake. That's why I do this here, so that we have something to record. So now I'm running a profile. Here I have a little NAV code unit that's just creating sales orders and posting them. Fire. And now the server starts to record. I have filtered every query that takes more than 100 reads. Again, in reality, I would have a higher filter. So just recording a couple of seconds. So here we have about 850 lines recorded. So which is the poor guy who wants to sit in front of the screen and investigate 850 line by line and make mind up, is there something strange? Is there something I need to fix? No, definitely not. But first, what is recorded here? So for those who are not so familiar with the profiler, I have recorded always the so-called completed events. So when SQL Server has finished an operation, because then I know how long it took, what reads or whatever it takes. We have a special way how Navision is querying the SQL Server. The first event I'm recording is the statement completed. Statement completed, that's the event when NAV converts the CAL code into a SQL statement. And this statement is actually wrapped into a stored procedure. And this is the reason why the statements don't show any filter values. You always have these placeholders here. And the next step is to execute this procedure. That's the remote procedure call completed. This is the idea of the previous procedure. And these are actually the filter values. So what the client actually wanted is item number 4050, variant code blank, and location code gelb, that's yellow. So that's just something to know. NAV is doing it this way because when everything that runs through stored procedures is actually cached by the so-called procedure cache. So benefiting from the caching mechanisms of SQL Server, that's the reason actually why this is done that way. Okay, so now I have a query, a trace with lots of problematic queries I need to investigate or I want to investigate. And again, I don't want to sit there and scroll through. Again, that was a record of about 30 seconds. If you're running a trace for an hour or two or half a day or something, you will have thousands of lines. This is not an ISV session, so I do not tell you which tools, but make you aware that there are tools that can do an investigation. There are freeware tools that don't cost anything to investigate such traces. But what all tools actually have in common is they proceed like this. In SQL Server, it is possible to read such a trace file back into a table. That's what this function here is doing. And once you have it in a table, you can do anything. If you have it in a table structure, you can connect it with Excel, and then you do some filtering or whatsoever, sorting with Excel. Or if you're a little bit into SQL programming, you do your own scripting and do anything with this. And this is exactly what I have here, a little script pumping the trace into a table, and then do some little investigation and show it here. So it's just splitting up which tables are used and which kind of select, the filter used, the sorting order used. Then I have all the consumption data here and the occurrence. Have in mind that this here is microseconds. So that's 1 millisecond it took. Yeah, and of course I can sort it as I wish. So this is something where I can decide what is a problem I want to fix, I have to fix. What's a recurring problem because due to the code, due to the business process, and what is a single event. Yeah, because you all know that a user falls asleep, hits the keyboard, sends some stupid filter and causes some stupid scanning. Happens every day. Yeah, you know that, obviously. Yeah, there's the saying, most of the problems are half a meter in front of the screen. Don't comment on this. Anyway, so this should help you to decide what you want to fix and what you can ignore or down prioritize. So here I have a query that was executed very often. And yeah, for Kronos, consuming a lot of things. So this is something I want to troubleshoot. So the problem now is, if I want to fix this in NAV, it will take forever. Because if I find this query, in these statements or anything, we don't have the slightest clue about where it's coming from, where it's originating from which NAV code this was filed, which code unit it was, or whatsoever. I know that because I have programmed this, and maybe you know it for your customers because you know Mrs. Smith on the sales line, she's processing orders or something. Then you roughly have an idea about the business process. But mostly you won't know that, yeah, because we have this domino code in the vision that this is validating this and this is validating the other thing. So where the hell is this coming from? So troubleshooting within NAV is a hell of time consuming and yeah, mostly not giving you success. And I would like to show you how to troubleshoot this easily with SQL Server. The first thing we need to do, or we can do, to really investigate this in all details possible is to copy this query into the Management Studio. I will copy this query and I will copy the corresponding remote procedure call so that I have an example about these filter values. Oops. So we will have something like this. I have a statement with these placeholders here. And if I want to rerun this in Management Studio, no way. Yeah, it's unknown parameters and stuff. But I have the remote procedure call. Oops. And sorry, doesn't work either. Of course not. Because that's a stock procedure created on runtime, it's vanished. It's not there anymore. So I cannot do this. But if I want to know exactly what's going on, how SQL Server was processing this, I can combine this. What I can do is now take in these filter values and replace the parameters so that I have a query that looks like this. And now I can execute this as an ad hoc query in Management Studio. So the first idea is here I can see what is the result. If it was not a sum query, how many records were retrieved? Is it plausible to have that many reads? No. In this case, not. Have in mind, in Management Studio, you can also enable kind of statistic parameters, like these here, statistic IO1. And if this is enabled, you'll be able to also see the IO in the Management Studio. There's CPU, statistics, and whatsoever you want to see. So in this case, I can reproduce the problem. So I have the same number of bad reads like I have recorded in the profile. So that's good news. Have in mind, this is an ad hoc query. Ad hoc queries are no cursor queries. Everything you execute in the Management Studio is always interpreted on the filter, on the where clause. So if you have a problem you cannot reproduce, then it could be because NAV is calling or querying with a cursor, Management Studio not. So that's a difference. So just to be aware of this. And what I also have shown briefly, here is a shortcut Control M to enable the execution plan to see in all detail what's going on in SQL Server. Again, a clustered index scan on the item ledger entry table. This is hell if that happens. This is a small table, in this case, just a few thousand records. In real life, imagine ever the full table has to be scanned. So, how to troubleshoot? Obviously, we don't have such a helping structure to help the SQL Server to find the data quickly. So, put our index finger and point him to the direction. So what I do here is in Management Studio, creating an index. And when I do this in Management Studio, I just have to regard a few guidelines. First thing is never match or never use the Navision naming conventions. So of course, never name an index $123 or something. This will raise hell. When you create an index, SQL Server has actually different requirements than a key or so in NAV or the old native box. For the SQL Server, the important parts of a query actually are the operators used. So the first rule is having equality columns at first. Equality columns, that's all kind of columns that are queried with an equal. And at the right-hand side of an index, then the inequalities, so greater, smaller, and whatsoever. And besides that rule, there's a rule about selectivity. SQL Server wants to have fields which are highly selective in the beginning. Selectivity means a field is highly selective if you have many different values of that field. For example, in the item ledger entry table, you have this entry number. Every record has a different entry number. So entry number has the highest selectivity. Yeah, because that's a field actually how SQL Server could most easily identify records. That's why they want to should be in the beginning. And this is actually a challenge when you're really doing the troubleshooting, because you will find stupid queries coming from NAV, because FinSQL is adding some filters in some cases, where you will find stupid filters on smart fields, something like greater entry number or something. And so what? It's selective in the beginning, but it's an inequality in the end. Where to? This is something you have to find out for yourself. Actually, this is what I want to encourage you. What I'm showing here, do that. Just do it, because you can't do anything wrong. And I'll show you why this is actually an easy task. So in this case, I have all equality columns. I'm not using variance. So I have more different item numbers than variant codes and location codes. Again, variance I'm not using at all. So my highest selective field is in this case the item number, followed by location number, variant code. Now creating this thingy here in Management Studio. Of course, this is something I could create in NAV as well. I could create such a key, but I cannot do this during business hours. If I want to change the item ledger entry table, it takes ages maybe to redesign it if you have many companies. Or users get an error, the definition of table, something has been changed. If you have done this terrible mistake and using enhanced security model, then you need to synchronize. No way during business hours. So if you do it in SQL, no problem. The worst thing that could happen is that the users get blocked while you're creating this index. Yeah, but they want to have an optimized system, so they have to accept a little rough road during this troubleshooting. Okay, and when I have this index in place, I can instantly check if this solution indeed is a solution or not. So I'm executing this query again. Ha! And now the I/O is down to 2 reads. That's ringing a bell, and checking on the execution plan, I see that my index is used. As I want. Hooray! So the solution was a solution. I could bring it down from 200 to 2 reads. And have in mind that it was a Cronus fake. In reality, that would mean, like in the previous example, going from 130,000 down to 2, or from 2 million reads down to 2 reads. So that's a tremendous improvement, speeding up the system remarkably. So that was obviously successful. But what else is it doing here? So it was using the index, but still we have such an operator here we haven't seen so far, a key lookup operation. A key lookup that's looking up the clustered index, the $0 thingy here. And the reason is that my index exists of these 3 fields: item number, location code, variant code. Where should SQL Server get the quantity from? It's not part of my index SSI1. The quantity is not there. The quantity is part of the table, so part of the clustered index. So that's the reason why it's looking up the clustered index to retrieve the quantities. We can also see this when with the mouse hovering. Yeah, you see it's the quantity that's important here. Okay, so that means, and this is now what we cannot do in NAV, I can create an even better index. And now using this included columns. So I create the same index, just a different name. And now I attach to the leaf node level of this index, I attach this quantity. So I'm executing, if I find it, this one, and rerun the query. So the I/O in this case is not further improved, but the execution plan. And hovering, we see now it's the second index that's preferred, because in this case, this single index contains everything. It has the pointer, plus the quantities. So it's like Red Riding Hood jumping through the forest with its basket, collecting mushrooms or whatsoever, and when it's get the quantity, it can instantly ship to the client. Yeah, red shirt. Okay. Yeah. Anyway, so using this smart feature of included columns means that we can create an index that is 100% optimized. This index, with this indexes, we have the smallest I/O, the fewest number of reads, and the fastest CPU time. So it cannot be quicker. So it's impossible to improve this further on by simply using SQL features instead of NAV thingies. So now I have a solution, or at least I think I have a solution, which works properly in the Management Studio. But who tells me this is working with NAV too? So that's a good guess. But as I'm doing this during business hours, I get my feedback instantly. Because, of course, SQL Server knows exactly which index it is using. So there we have a dynamic management view looking into the index usage stats. So with this, I can check. This is filtering on these SSI indexes. And I can see, okay, both indexes have been used once in a seek. So that was the demonstration actually in Management Studio. So now, if my NAV is posting again, now I'm just updating this query. You see something? Yeah. The number of seeks is increasing. So I have an instant feedback that my solution is working. And I will not see it just from the figures that the index is used, although the clients will experience this. Yeah, depending on what I have changed. If I have cut this query down from, I don't know, several thousands of reads and maybe 2 seconds runtime and so down to 2 reads and a microsecond, of course, that's a dramatic improvement where the user experience really will increase. I'm gonna stop that. Okay. So to roll this up a little bit, there are problems we have in NAV with indexes because you know, we have indexes in a certain way. We have cursors, we have keys. There will be always something stupid in NAV. You will always have queries that consume a lot of I/O, taking ages to execute. Troubleshooting this within NAV is hell. You all know the NAV code. It's a gazillion of lines to troubleshoot, and yeah, it's just a hell of work. With SQL features, it is easily possible first to find out about problems, to really having hard facts. It's not just what you usually get from the user, oh, everything is shit, nothing's working. No, you can put it down to the fact, to the number. You can really say that's that many reads, that many CPU milliseconds and stuff. So you can identify problems. You can do a very, very detailed investigation, starting with the script to quantify them. Then you have execution plans, query statistics, and everything. So you get the full picture of what's going wrong. And in most cases, I dare say it's 90% of all query problems, it's missing indexes. It's because you have insufficient index structure. And the easiest way to fix this is to do it on the SQL Server side. You don't have to fiddle with NAV with all the consequences. You can do it on during business hours. You get instant feedback from the system, from the hard facts, and also from the users, because suddenly it's not, oh, everything's shit. Now, hey, it's quick, it's fast and stuff. So, yeah, imagine if you do this in NAV. Yeah, so after business hours in the evening, I have to change item ledger entry, bring this to life. It doesn't work. Oh, pity. If this doesn't work, well, there's a drop index command, yeah, and then it's gone. In NAV, a pity, I have to remove this index tomorrow evening. And so on. Nah, that's okay. So, and this is really what I want to encourage you. Do this in SQL Server to have a quick benefit. And afterwards, you still can make your mind up if you want to have this solution in some kind as a key in NAV, if it's compatible. Because that's something you can do afterwards. First thing is solve the problem. Happy customer. Yeah, fast system. And when you know what is the goal, what is the target to reach, Then you can afterwards think and do it in NAV. Or just leave it in SQL. But actually, that's a philosophical question. One thing I want to also mention here is the sustained engineering once provided also a script which is looking into the query caches. I have the link here to the blog. So if you don't do it with a profiler, this is instantly looking into the cache and having also a similar idea to display the number of reads, execution times, and so on. So that's also something from Microsoft you can use. So it means the worst problem is wrong or missing indexes, which we can fix now. No problem. So what helped us in this first part was this index usage statistics. Because actually we have another problem. And this is because NAV is totally over-indexed, so to speak. That means there are so many indexes, keys and indexes, that are just causing super load on the system and slowing down write performance dramatically. The reason is simple, because we need to have a key for every sorting order. So what we often do is we just copy-paste a key and change the last two fields. Now just look into the sales line table and you find 5 keys, all starting with document type and something else. So, and usually every key corresponds into an index. And that's why we have many, many, many indexes, especially partners that having lots of add-on solutions, and every add-on is adding 5 and 10 indexes to the important tables. But SQL Server is actually a smart thing. It will pick out the best index available and ignore the other ones. So what we need to do is to find out which indexes are used indeed. And when we know which indexes are used, we exactly know on the other hand which indexes are unused. This is what we can do with this statistic, this index usage statistic. The only problem is here, quite a practical thing is, in NAV, not every process is run every day. Yeah, so it's not going on everything. So the problem with these statistics is they are always reset if the service is restarted. For example, if you install a service pack or an update, service is restarted, all statistics are 0. And if you do an index unused investigation, system will tell you all indexes are unused, drop them. Hooray. I hope you agree with me that this will probably raise a tiny problem. No. So what we need to have is a reliable statistic about the actual index usage. And also this is fairly simple. So I recommend to do is I just create a little table here. I call it index usage for a certain reason, which will give me an error because this table already exists, doesn't it? Yeah, it does. Yeah. And now what you can do is you can create, for example, an SQL Server agent job, which periodically just saves the system statistic. So I just have a job running every 2 weeks, every month, every week, whatever frequency you think is suitable, and then I just copy the system statistic. So if the service is restarted and the stats is nulled, is reset, who cares? Because I have my record of this. And then when you say that you have now investigated for a reliable period, yeah, that's the important thing. So to monitor really everything that is important, like end of month procedures, quarterly reports, physical inventory, maybe end of year processing and something. When you say, okay, now we have seen everything that is important, then you just can run an investigation. And here this query is querying the maximum usage. This is already filtering. So here I have some indexes that have never been used, but often updated. So they were causing load, but giving no benefit. Now, in the period I was recording, which is just a couple of hours since I started this box. Because the risk is if you get rid of such an index and then suddenly there is a report which needs this specific index, well, then maybe this report will take an hour instead of a minute or something. Then the next important step is here. If you browse this in the internet, you will find lots of queries and examples that propose you some drop index statements and how you can get rid of these indexes from a SQL Server perspective. Never, 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 did I say never? Never, really never, never drop an index on SQL Server side if it's an Navision index. You can do this with your own stuff, never drop an NAV index. Perception and reality, this is important. So if you have an index defined in NAV and it does not exist anymore, then sooner or later you really will hit the wall. So the shit will hit the fan and you will stand in front of this fan. Yeah, so no, if Navision indexes are dropped, then Navision has to drop them. And in this case, for example, document dimension 357. Technically, what you have to do is, that in this case we know that's $1. This is $0. This is $1, and this is why we have this property maintain SQL index. So I have to remove this, and then Navision will drop this index, and then the Navision expectation matches the SQL Server reality. So this is important that both worlds are in sync. Never do this with the enabled flag. Enabled is completely disabling the key, not just the index. So you cannot use this key specifying in a set current key command or table view property or whatsoever. So then it's totally out of NAV world. And we're not talking about NAV world, we're talking about SQL thingies. So this is the flag to fiddle with. In this case, that was actually quite easy to pick out the index $1. It will be a little bit trickier if you have table and tells you $35, because it's not necessarily really the index number 35. If you count them from the top, there can be gaps in it and everything. So that's tricky business. Again, there are tools that can do that easily with a few mouse clicks to relate this to the right Navision key and stuff. So that means, on the one hand, we will add indexes to improve queries, and on the other hand, we get rid of indexes we obviously don't need. So that means that's just a matter of time and effort you want to spend for this troubleshooting, but sooner or later, this system only has the indexes it really needs. So you can find the right balance between read and write performance. Improving the read queries with maybe added indexes and improving the write performance by getting rid of unused indexes. Yeah, so far, so good. If we have indexes, regardless how they are created, where they are coming from, to round up this whole index thingy, indexes require maintenance. That's really crucial. Maintenance will not make your system faster. It's like changing oil with your car. Your car will not go faster if you change periodically the oil, but if you never do it, sooner or later your car will break down. And this is exactly with index maintenance the same. Indexes fragment. That's a natural thing because you insert data, you delete data, you change data, so you have actually gaps, let's say, in these index trees. And the more fragmented an index is, the slower it performs. So it is absolutely necessary to periodically maintain these indexes, get rid of unused space, keep them small, and so on. In standard SQL Server, we have actually a maintenance plan feature. And this maintenance plan provides actually two tasks for this job, for defragmenting indexes. That's the reorganize and the rebuild. The difference is briefly, a reorganize just takes care about the most detailed level of an index, the leaf node level, but it will not give an optimal result. as the reorganize is working on a very small granularity that's causing almost no blocking issues, so it's running very smooth while parallel transactions work. But it will record a hell of information into the transaction log. The transaction log will increase in size dramatically. If a reorganize runs throughout the whole database, it could happen that the transaction log has the same size as the database. So that's the reorganize, and the rebuild, that's the big brother. It's taking care about the full index, giving the best result from a defragmentation perspective. But actually it's causing a hell of blocking issues because it's completely locking the index. So it's not possible to work with this at all, except if my mouse is responding. There's a feature, online indexing. I apologize for my German environment, but I think you get the point. Online indexing, that's a feature you can also enable in standard edition, which will raise an error because it's an enterprise feature. Online indexing means that also on a smaller granularity, locks are established, they are released earlier and causing less problems. So the reorganize, the rebuild. If, for whatever reason, you want to do this or have to do this with this standard feature, I always recommend do the rebuild. It's the better one because you can do also other things like adjusting the so-called fill factor. Here you can define an amount of free space. Normally the data pages of SQL Server are filled up completely. So if you want to insert something into a filled page, SQL Server needs to do something stupid that's called page splitting. By applying some free space, you just have a reserve for faster insertion of data. And again, there is ways to do this properly. If you do this with this, best practice recommendation, my recommendation is to have a free space, something between 5 and 10%. That's reasonable, and that works with, I dare say, almost all databases. Yeah, but, and this is actually totally insane. This is provided by Microsoft. I just want to highlight this because the next thing is also by Microsoft. Having a think again. Defragmenting indexes, that's the idea. If I want to defragment something, well, shouldn't I know if it's fragmented? And so it means like defragmenting a disk, I only do this if I know that disk is fragmented. So the interesting thing is that, of course, SQL Server knows exactly if an index is fragmented or not. Index physical stats, that's a dynamic management view. And in this, you will find an indicator telling you the fragmentation degree. So you can find out if an index is fragmented, if it needs indeed maintenance. And now this is really an insult almost. In the example D, delta, Microsoft is actually showing us how to do proper index maintenance instead of the maintenance plan. So it's curious, but it is. I'm always wondering why this feature is not shown in the maintenance plan here. I have copied this script so that you can see it a little better. And because and actually this script is around in the internet for ages. You find it with SQL Server 2000, just with a different technology. So this is really best practice. And the idea is simply, where is here? First, we pick out all indexes that are more fragmented than 10%. Everything below 10% could be ignored. That's totally acceptable. And then we just distinguish. If the fragmentation is up to 30%, then we do the smooth reorganize. And if the index is fragmented for more than 30%, then we do the full rebuild. This script is not 100%. There's several things you could improve, but even just by copy pasting this to an agent job is better than using the maintenance plan. You cannot do, this script cannot do some fill factor adjustments, but this is a piece of cake to add. Yeah, and if this is executed periodically, I dare say at least once per week, then your index should hum. Yeah, and the last thingy, and that's really all in everything then. Every index comes with a statistic. These statistics tell the SQL server about these selectivity thingies and so on, about density of data and whatsoever. I have skipped this due to the time. Also, the statistics need to be updated. And this is something you learn in every SQL DBA course in the very beginning. Don't do the statistic update automatically. You probably know that in the database properties, there is auto update and auto create stats, which is usually enabled. That way, you should not do this because that also is decreasing, downgrading performance. Better to disable the autopilots and compensate by manual maintenance. And this also could be done by the maintenance plan, whereas a statistic task, or even better, because it's also just smarter, these two standard procedures, SP update stats and SP create stats. So this will take care about your statistics. To have correct information about that, I recommend to run this at least once per day. And then you have all and everything in place. Okay, so that was the full enchilada. Something to mention, all this about execution plans. If you have never done this before, it might look complicated. Believe me, it isn't. We're not talking about rocket science here. You find some links into the internet or also in the online help of SQL Server, how to read execution plans, what these operators actually mean. So the scans, that's the bad ones actually. That's the one you don't want to have, and the seeks is what you want to have. And again, just try it. Just try it. When you do this troubleshooting, create your indexes, check out if it's working, if it's not working, because that's the best way to learn this. Yeah, and after 8-9 years, you have it in flesh and blood. No problem, believe me. Okay. Yeah, little summary. Avoid the cursors. If you have cursor, a cursor is not necessarily bad. A cursor is only bad if we have a gap between filter and sorting order. Best thing is, of course, to avoid it by using properly find set or find first or whatsoever. Yeah, then you've seen that it's actually easy to find out about problems, to troubleshoot them by creating your own indexes. It's almost as easy to remove unused indexes. Here, the important thing is really to have a representative period of monitoring. And last but not least, we need some maintenance, which is also a piece of cake. Yeah, the resources where you can find more about this. Once upon a time, I have published a little book about this. But there are also standard documents about from Microsoft you find on Partner Source or on Mibuso for download. And of course, the most important resources is the internet, where you find all the details about everything. And I don't have to tell you to go to the communities, because there you don't get the facts, you also get the experiences and the opinions, and that's often more important than the facts. Yeah, I think we have time left. Have we? Yeah, oh, perfect. You have questions. So, it's really tricky to see you because of the...
Hi there. I have a question that came out from some of the early code samples that you gave at the beginning when you were in NAV, specifically the find set and the find first. Would I be correct in understanding that the find set implied that the set current key function is now redundant because SQL will find the best key for us anyway, or is there still value in using it?
Well, first thing is you should always apply a set current key if sorting order is important, of course. That's the first rule. The second is a find set does not necessarily need a sorting order because it's interpreting the query on the filter, and if you have an index that matches perfectly for the filter, then the sorting order is unimportant. You only have to be aware if your actual result set is exceeding the stop clause. If you have more than 500 records, then the data will be pumped by a cursor, and then the sorting order could be important. So this is something to decide individually if it's necessary or not. And I recommend to react on this problem. If you have a key available, then use it. If it's no harm. If you have to create a key for that, I would not create it at first. See what happens, and if you see okay, it doesn't work, even though you're using a find set command, because there can be other reasons why SQL Server is taking a stupid decision. Then to react on this problem and then maybe create a key if it's necessary.
Sure. Okay. Thank you.
Hi. My question is also about the beginning. You said to avoid the usage of indexes from Navision or something. I can give an example of something and would like to hear about from you if it's a good solution. I had a database with 200 million customer ledger entries, and a report took 5 minutes to count them. Then we saw that Navision always adds the clustered primary key to the index, whichever you use. And so we used a specific SQL index to avoid that. And we had to put that index in the dbconfig table, if I'm not mistaken. Is there a simple way to force the use of an index without the primary key on it? Because if you use set current key, SQL will add the primary key to it. Can you avoid that on an easy way?
Not really. So what you're talking about is this index hinting, that you create an index and then in dbconfig you apply a so-called index hint. That's all described in some Microsoft documentation. And then NAV will add a clause to the query which tells with index $2. So forcing SQL Server to use this index and don't decide yourself. This is actually, it depends on what version, that's 4 or 5, I guess, isn't it? With an older SQL Server 2005 probably. Yeah, this added primary key, indeed, that's not nice. But the problem is that NAV will add primary key filters automatically when you loop through results. And in this case, it could be smart to indeed have this additional primary key. But there is no way, except for this dbconfig thingy, to force NAV to use this index. The only thing you could do, and this is really something to handle with care, if you go to the key properties, and then you just copy the fields from key to SQL index 1-to-1. In this case, the index will be recreated without the primary key. This gives very small benefit meanwhile, because that's going too far, because the actually primary key usually is clustered index, and clustered index is implicitly part of every other index. That's why it's usually redundant and you can get rid of it. In some cases not. The problem is, and I just want to highlight this again, with this SQL index property, I'd rather not use it. Because if you have a cursor always tries to look up an index matching to the sorting order. The sorting order is defined by a key. Out of the box, it is granted that every key we create has a corresponding index, which 100% matches to the key. So if a cursor is executed and looking up this index to this key, it always will find at least an index. If you now overrule this translation key to index, there's no more match anymore. And you will find some blocks of the sustained engineering. This could lead into really serious problems, ending up that Navision will change the sorting order on runtime. So you define a set current key, and suddenly Navision is using a totally different key. Because of this, it's described in detail in these blocks. So the fail-safe way is to leave it alone. And if you have to change with indexes, I recommend to do this on SQL server side, leave NAV alone, and try to create your own smart indexes and then do something with it. Yeah, hope this answers your question.
Hello. Just a question about the maintain SQL index feature. We have a lot of add-ons that we develop for the Navision system. Is it then better to disable the maintain SQL index and then just move everything to production and then just see if we need to create a SQL index separately?
No, I wouldn't do that. Because most of the indexes in NAV and most of the code is working perfectly. If you run a profiler trace without any filters, you will see that at least 99.9% of all the queries are executed perfectly. The performance problems actually originate from a very small amount of queries, which just screw up everything. So everything is fast, and then you have one query in between that takes 5 seconds, and all the good performance from before is vanished. So I really recommend to always react on the problem, identify the problem first, and then work on this. Because usually if you do some troubleshooting, you might add indexes something between 5 or maybe 30 or something. Yeah, it depends on, we have larger systems where we probably have added more indexes. But that's actually a rule of thumb, just let's say 1-2 dozen of indexes that you really need to add. And I would not encounter this problem because I think that would be annoying for a customer if you install a system that screws from the scratch. It doesn't work at all, and then you react on everything. So leave it in standard and only react on the problems. That would be my advice. Any questions? The lady here.
Can we use the client monitor for identifying the bad queries in NAV?
The client monitor, actually, you need to know which client has the problem. If you know roughly where the business process is, which user is affected, because you need to be on the client to execute it. So if you know this, the client also will show you this, but not in this details as the profiler. A problem with the client monitor is that you cannot record that many lines, because if the record is too much, then it could happen that the whole FinSQL exit crashes or something like this happens. What I recommend is to start with a profiler to see maybe if it's a certain user, a certain business process that is affected. And if you know where the problem is originating from, if you can have a closed circle around this, then you can go to the user and say, okay, you guy, now you process an order and I switch on the client monitor. And then get the further detail, because then you have this big advantage that you can switch into the NAV code. Because that could also be a problem. Maybe it's not an index problem, maybe it's really a filter you need to change or anything. Another thing I have in mind when it's about profiling and everything, with a profiler you can also find out the number of iterations a certain how often a certain query was fired. Just think about it, because some customers are sitting here. We had a problem, and exactly with profiler we found out that the prepayment module just sucks. Yeah, because suddenly posting routines were taking ages, and we have found this out with the profiler because we have seen that certain queries were executed 10,000 of times for no reason. Yeah, and so we started with the profiler. And in this case, I think did we use the client monitor? No, no. But once you have a focus, then I would suggest to use the client monitor.